So in this video, we will be talking about introduction to CNC. CNC machining is a manufacturing process in which a pre-programmed computer software will determine or dictate the movement of factory tools and machinery. The process can be used to control a wide range of complex machinery, from grinders and lathe to mills and routers. So what does it means by CNC? The term CNC stands for computer numerical control, and the CNC machining definition is that it is a subtractive manufacturing process which typically employs or use computerized controls and machine tools to remove the layers of materials from a stock piece that known as the blank or workpiece and produce a custom designed part. And this process is very suitable for a wide range of materials, including metals, plastic, wood, glass, foam, and composites, and has many applications in variety of industries, such as large CNC machining and CNC machining aerospace part. So when we talk about in terms of the machine itself, the CNC machine definition is that it represents the actual programmable machine that is capable of autonomously performing the operation of CNC machining. So in short, we can say that CNC machining is a manufacturing process that utilizes computerized controls to operate and manipulate a machine and a cutting tool to shape stock material. For example, metal, plastic, wood form, a composite, and many more into custom parts and design. So while the CNC machining process offers various capability and operation, the fundamental principle of this process remain largely the same throughout all of them. And the basic CNC machining or the stages that involve in CNC machining includes all these steps. The first one is to design the CAD model, and secondly to convert the CAD file to a CNC program. The third one is to prepare the CNC machine, and finally to execute the machining operation. CNC machining is a manufacturing process that has a wide application, like I have mentioned previously, in variety of industries, including automotive, aerospace, construction, and agriculture, and able to produce a range of products such as automobile frame, surgical equipment, airplane engine, and hand and garden tool. And the process encompasses or consists of several different computer control machining operation that include a mechanical, chemical, electrical, and a thermal process that remove the necessary material from the workpiece to produce a custom designed part or product. And here we have some examples of the most common mechanical CNC machining operation. So we have a drilling, milling, and turning. CNC or a computer numerical control machining is a subtractive manufacturing technology where the parts are created by removing material from a solid block, like what we can see the figure here. So this solid block we call as blank or the workpiece, and we cut it using a variety of cutting tool. So basically, in short, the basic CNC process, we can divide it into three major steps. First one is the engineer first design the CAD model of the part, and in the second step, the machinist will turn the CAD into a CNC or G-code, and finally set up the machine. Yes. So for our discussion, we will focus on the CNC machines that remove material using a cutting tool. These are the most common and have the widest range of application. Other CNC machines include laser cutters, plasma cutters, and ADM machine. So in the figure here, we have types of CNC machining. We have three-axis CNC machining and multi-axis CNC machining. CNC milling and CNC turning machines are examples of a three-axis CNC system. And these basic machines allow the movement of a cutting tool in three linear axes relative to the workpiece, left to right, back forth, and up down. Three-axis CNC milling machines are very common as they can be used to produce the most common geometries. They are relatively easy to program and operate, so the startup machining costs are relatively low. And here we have a multi-axis CNC machining. And multi-axis CNC machining centers come in three variations. We have a 5-axis index CNC machining, CNC milling. We have a continuous 5-axis CNC milling and mill turning centers with live tooling. These systems are essentially milling machines or lathe enhanced with additional degree of freedom. For example, 5-axis CNC milling centers allow the rotation of the machine bed or the tool head or both in addition to the linear axis of movement. So programming is a fundamental skill for all types of CNC machining, even as automation and new technology seems to be replacing programming tasks. And every machinist still needs to understand how the programs and tools work. Whether you are new to CNC programming and its most common language, that is the G-code, or you have been writing code from scratch for many years, CNC can still feel like a foreign language. And to make things worse, every machine speaks a different dialect that you need to understand. Do you understand what they're saying? And here we have a G-code basic. You need to know to efficiently understand and write programs that produce a high quality product. So in the last video, I have introduced you to CNC and some importance of programming and CNC. So in this video lecture, we'll be discussing more on G-codes. G-code is a programming language for CNC that instruct machine where and how to move. Most machines speak at a different dialect of G-code. So one machine might differ from another machine, and so the codes vary depending on the type, make, and model. Each machine comes with an instruction manual that shows that a particular machine code for a specific function. So G-code stands for a geometric code. And follows some variation of the alphanumeric pattern, as we can see here. For example, N refers to a line number, G refers to motion, X refers to horizontal position, Y refers to vertical position, Z is depth, F is feed rate, S is spindle speed, T refers to tool selection, M refers to miscellaneous function, I and J refers to incremental center of an arc, and R refers to the radius of an arc. And at the bottom here, we have a figures that shows a common operator panel. As we can see here, a CNC machine is normally controlled by a computer and software. However, most CNC machines have a range of controls for manual use. So what is a G-code? alphanumeric codes are used for programming as they are a simple way to define motion and function, to declare a position, set a value, select an item, and switch something on and off, such as a coolant, spindles, indexing motion, axis, locks, and many more. So, for example, for example, here we have examples of a G-code. Okay, so take for example this line of code, and this generally indicate a linear fit move G01 to the given XY position at a fit rate of 20. It is using a tool 1, and the spindle speed is 500. So miscellaneous function will vary from machine to machine. So in order to know what the M code means, the machine instruction manual will need to be referenced. So in short, we can say that the G code is used to determine the geometry of a tool movement and operating state of machine controller. A G code is defined using the G address, letter, and a 2-digit number, as we can see here. So this is the examples of a line of code that I showed you previously. Multiple lines of a G code like this combine to form a complete CNC program. Your CNC machine will then read the code one line at a time from left, from here to the right, and top to the bottom, like reading a book. And each set of instruction is on a separate line or a block. So everything a machine can do is based on three basic types of motion. First one is a rapid move, a linear move to an XYZ position as fast as possible. And secondly, we have a fit move, a linear move to an XYZ position at a defined fit rate, and we also have a circular move at a defined fit rate. So every G code tells the machine which variation of these basic motions to perform and how to perform it. X and Y are Cartesian coordinates. Cartesian coordinates. For horizontal and vertical position, and Z represents the depth of the machine. These alpha numerals will follow the motion function G to declare the position of the machine. And next, F will determine the fit rate for the fit move or circular move. And while S will determine the spindle speed. So F determine the fit rate. And S determine the spindle speed. On the other hand, T is used to select a tool. Other alphanumerals used in programming might include I, J, and R, which have to do with arc, centers, and radius. Now we will be talking about miscellaneous codes. What is a miscellaneous codes? The line miscellaneous codes can be defined as the line of a program codes that tell the machine how to perform an action. A line of a program might also include M codes. Okay, miscellaneous codes can also be referred as M codes, which are generally codes that tell the machine how to perform an action. Perform an action. While not guaranteed to be the same across machines, some common standard M codes are. You can see here the standard M codes. For example, we have a M00 means a program stop, M01 means optional program stop, M02 end of a program, M03 spindle on clockwise, M04 spindle on counterclockwise, M05 spindle stop, M06 tool change, M08 flood colon on, and we have a M09 that indicates a flood colon off, M30 end of program, return to start, M41 indicate a spindle low gear range, and M42 spindle high gear range. So these are some examples of a standard M codes. So in short, M code can be defined as the machine control language for a CNC machining. It is used in combination with Gcode, used in combination with Gcode to switch various machine function off and on.